Okay, so on agenda-wise today, the goal is to get you guys ready for Lab 7. You all are working on Lab 6, which is creating the database schema. And you have to work towards creating, so once you are done with assignment 6, you'll start your work on assignment 7, which will require you to basically code the schema created in Lab 6. So Lab 6 was about designing tables and relationships. And the output was a row notation diagram. So that is coming due today. And then in Lab 7, we take the DB schema. We take the DB schema and we convert that to syntax. So using create table and create and alter command. And that's what we're going to be learning today. So we'll get right into it. So creating database objects. There are creating objects. There are 5 kinds of objects. So there are 5 types of objects: tables, views, sequences, indexes, and synonyms. The table becomes the basic unit of storage that's composed of rows and columns. This is what you guys are designing. This is what you guys are designing in Lab 6, and you're also coming up with a set of relationships for setting up the cardinality between the different tables. Then we have a view, which basically takes the subset of the data from one or more tables. And the view represents views created generally from a select statement. We have talked about creating views or creating the view syntax this earlier when we talked about key preserved tables. So it was basically create view as select. So then we have sequences. Sequences are objects that generate unique values for primary keys. And then we have indexes that improve the query performance. Indexes are also table-like structures that exist in memory that contain the value that appears in the where clause along with row IDs in memory. So what indexes do is, just like an index in the back of the book improves the time it takes to find a concept. We go to the back of the book, look at the description of a concept that's listed in alphabetical order, and then look up the page number. Very much like that, we look up a value and find the row using an index. And synonym is alternate name given to an object. So if I want to hide or encapsulate the name of an object, I can give it an alias or a synonym. Or sometimes if I have a very large, a very long name for an object, if I have a very long name for an object, then I can use a synonym. So we're going to learn these 5 objects, and we're going to end up using these in our Lab 7. There are some naming conventions that you do have to keep in mind when naming these objects. All the objects you create must start with a letter, and should be up to 30 letters long, and can contain these characters A through Z, lowercase and uppercase, numbers, underscore, dollar, and hash. We also have to make sure that we do not duplicate the name of another object used by the same user. 2 different users can have same object names. Like in the database that you guys are working on, we have EMP table, and we have department table that exists for all the different users that we have in this class. So we probably have, for the 50-some user accounts that are being used this quarter, there are 50 EMP and department tables. So you can definitely duplicate object names across different users, but not for the same user. When we have a user that has its set of tables and indices and objects and all that, that is referred to as a schema. So, and you cannot use reserved words, like you cannot name a table create or select for within the naming conventions. So this shows a simple create table statement. So you can see that we start with create tables and specify the column types, and we have a default expression. One of the things you can consider doing is downloading the SQL reference manual from Oracle's website, and you can get more detailed information on each of the DDLs that we are covering, or the data definition language that we are covering here. So how we translate this into an example is something like this. We say create table, and then we specify the table name in lowercase. Generally, the convention is to use uppercase for keywords, and then we specify department number, department name, and location as columns, and then the different data types: number, varchar, true, varchar, etc. So the different data types that we have, we're going to go through those in depth in a moment. This is how the create table statement starts. There's also other parts of the create table where you end up specifying constraints, etc., and we'll talk about that. So numbers in varchar 2 represents the number of characters. And that is not to say that's the max size, that's the starting point. So varchar 2 is a variable length string, and each char is 1 byte. So unlike Java where a char is 2 bytes. You can use other you can have access to other user schema. So like if we have Bob's schema and Sally's schema, we can use, if I'm logged in as Bob in SQL, I can access Sally's objects by using Sally dot object name. The point is that Sally as the owner needs to give Bob access to those objects. How that is done is again a function of data security, which we will talk about towards the end of the quarter. So we end up setting up user security and then learn how to give access to other users. There are two types of tables in the database. There are user tables that are created by users, and it contains info for managing and storing. And then there is the data dictionary that is essentially a collection of tables that are maintained by the Oracle server to manage database information. Some of the tables that we will access in the data dictionary are right here. We will talk about tables here that have info about the tables we are creating. So there is a dictionary table called user tables that can provide you detailed information about EMP department and sal grade tables. Things about storage and all kinds of internal things that Oracle maintains. And then we have user objects, which has info about every database object you have created: views, indexes, synonyms, etc. And another one is user catalog. And this talks about tables, views, synonym, and sequences that are owned by the user. These are the different data types. So varchar 2 is your variable length character data, and char is fixed. So if I if I set up a size for varchar2 as 13 or 14, that's the initial size. But if the name that I enter for name, if I enter a value that is less than 13, then we will only use the number of spaces that are needed by the value entered. So if I enter Bob into the column that has a size of 13, we will only use 3 letters. Char, on the other hand, is different. You've had some experience with this because the employee table had a fixed size e-name column of size 10, I think. So if in that now you put the word Bob, what happens is we are going to end up using all 10 versus using 3. So that's the difference. Number is also a variable length numeric format where we can specify the size and the precision. Then we have date, which is the date data type we covered under when we talked about the functions chapter, and it maintains date and time values. Then we have long, which is a variable length character data set, which is now replaced by a CLOB, which is a single byte character data set for storing up to 4 gigs of information. We have raw, long raw, blob, and B file for other data sets. So blob will keep binary data up to 4 gigs, and binary file is something that is stored in the file system, but a reference of that is kept inside the database, right? So this is these are the different data types, and you'll end up using the first 4. So number is something like number is used for salary or commission in the EMP table. P and S are for specifying the size and the precision. So how many letters for the whole number and how many letters for the precision. Like for dollars and cents, you can say 7 and 2. So since we have talked about subqueries, we can also learn this point that we can create tables using subqueries. So this is called CTAS, or create table as select. And when we do a create table as select, we say create table from, and we specify a set of columns optionally as subquery. So as you can see, we have subquery. I mean, column option mentioning the columns is optional. Anything that is appearing in rectangular brackets is optional. If I have a subquery that says select 4 columns from EMP table, then those 4 columns become the columns in the new table that is created. So we can essentially define column names and default values from the select statement into the create table clause. And here is an example of how that would work. We say we create a new table called department by doing a select from EMP table. So we bring in those 4 columns: employee number, employee name, their annual salary, and hire date. We select that data from the EMP table and we restrict it to department number 30. And when we describe the table, you can see the 4 columns that are brought in along with the constraints and their data types. And in this case, we did not specify the column names, although the option for doing so is there. Obviously, the data from the EMP table is also brought into the new department table. This is one of the ways of creating tables. Then we have the alter table column, which is basically, once the table has been created, and if you want to do any modification to the table, you can do so using the alter table statement. You can add a column, you can modify an existing column, you can add a constraint, we have to talk about those, modifying the data type of a column, etc. Of course, with some, all of the things that can be done are with some limitations. So we have alter table, add column, modify column clause that you can consider working with. You use the add clause to add columns, like this. This will add a job column to our department table that we just created. I can modify the column data type. So I can say alter table EMP, modify ename to varchar to 15. So I'm going in the EMP table, and the length of the employee name column, which was 12, is now being modified to 15. So these changes that are created will only affect the new rows that are entered, but not the existing ones. So. You can add all kinds of comments to the into the database using the comments clause, comment on table, and then there are 4 dictionary views that allow you to view those comments. When we write code, oftentimes we expect writing, comment authoring, because there are things that, in the code there are certain decisions made that mean certain things, and displaying those, displaying the cause of those is helpful. Helpful in the sense that it informs other people of your intention for creating a column or something like that. Then we have constraints. This is also part of creating tables. This is enforcing certain rules at the table level for entering values. Constraints, the two that you are familiar with are primary and foreign key, and how those are used for keeping referential integrity. There are 5 constraint types that exist in the Oracle database: not null, unique, primary key, foreign key, and check constraint. So how are each one of these used? Well, we can create constraints at either table level or column level. We can define the name in the create table clause or the alter table clause. So when the table is created is in the create table statement, and after the table is created is in the alter table clause. And the constraints can be defined at column or table level. When a constraint is defined at a column level, generally we don't get a chance to name it, and a system generated name is given. So it becomes hard to look up the constraint information in the data dictionaries when we have a system generated name as highlighted that shows sys_cn or something. We can view constraint information in the data dictionary. So we'll talk about what those are, what dictionary names are that you can use for referencing that information. So we have create table statement showing the primary key constraint here as an example. So we've got our create table statement, and we have a not null constraint defined for a department number that is going to act like a foreign key. And then we are done with specifying all the columns, and in the very end we use the word constraint. This says that the constraint created is at the table level. And we give it a name. This is generally the convention that's used, where we specify the table name and the column name and what kind of constraint it is using underscores. and it's a primary key constraint on a column. The thing is that primary key column constraint can be added on more than one column. So you can have a composite key which has 3 columns or 4 columns in the primary key. Yes, we could use a alter table add constraint key so yeah, we would use alter table add constraint for department number for the for adding a foreign key later. So, so we have table level constraints and column level constraints. So we have column level constraints and table level constraints. We have the not null constraint that ensures that the null values are not permitted for the column. And these are defined always at the column level. So we have something like this. Department number not null. Then we have the unique key constraint. These can be defined either at table level or column level, and it gives a unique value for each field. So in this case, the department name cannot be duplicate. So and this can be achieved by simply creating a unique key. Here is the primary key and unique key created together. So the primary key can be also added at table or column level. So we already did the unique key right here, and here is the primary key. So both are starting with the constraint keyword, and then we have the constraint name constraint type and the column it's added on. Then we have the foreign key constraint, which is what we have just left here. The foreign key constraint is defined at either table or column level, and it defines a child table. So we have to reference another table here. So we are saying constraint name, foreign key, and foreign keys on department number. So we first specify the table on which the column in the primary table where the column exists, and then what does it reference. So we are in EMP table. We are saying that department number in employee table references department number in the department table. So that correlation becomes important between the primary and foreign key. This is how the primary key and foreign key constraints are set up. Then we have our check constraint. The check constraint is for defining a condition. We have to use this carefully because it can slow down the database. Because for every value that is inserted in the table, we make sure we go through the check constraint. So we say we've got the department number column, and then there is this is a column level definition because I did not add a comma after the column definition. So in this constraint, we are saying that the department number should be between 10 and 99. And that every time now a value is inserted in department number, we will ensure that if it's like 105, then the insert will fail, or the update will fail. And your question was answered, right? Just to make sure. So, adding a constraint after a table has been created. So we have alter table, table name, and we say add constraint. So we can use this to modify a constraint, disable or enable a constraint. So here is us adding a foreign key constraint. We say alter table EMP add constraint, and then the same syntax that we used earlier. Not necessarily, Susan. We don't have to drop the old constraint to modify. You can have multiple constraints in a column, so it depends on what you're doing. If you are adding a different constraint, you can just go ahead and do what's in the current slide. So like if a primary key constraint already exists and you want to add a foreign key, you can just do it like this. Okay? To remove a constraint, we can say alter table drop constraint. So this way I can drop the foreign key constraint. If I want to drop the associated keys to the primary key, like all of them, then I can say alter table department drop primary key cascade. And what that does is it allows me to drop all the corresponding foreign keys for the table. We can also disable constraints. Cascade means all columns that have had foreign key. So like one table can be a foreign, can have like we can have parent-child relationship in a table, and another table can be a parent, a child table can be a parent to another table. So cascading just gets rid of all the foreign key constraints that may be associated to one table. So, we can also enable a constraint. So using the alter table clause. So cascading constraints, it drops the referential integrity constraints across all columns using primary keys and foreign keys. So, and it can cascade constraints, as I showed you, can be used with cascade can be used with the drop column or disable constraint. Drop constraint or disable constraint. Excuse me, I misspoke there. So. And the cascade constraints clause drops all multi-column constraints defined on the dropped columns. So a fairly powerful statement for doing constraint management. Then we have
are data dictionaries. User constraints, so we have select, we have a dictionary constraint called user constraint table, and we can find constraint info here like constraint name and what are the conditions under which the constraint is created. If you want to look at columns associated with a constraint, then you can use user con columns. So this is user constraints or constraints added on or columns added on the user constraints. So in this case, we can look at for a specific table what constraints exist. And this is after the fact, obviously. So after a constraint has been created, if I want to use if I want to find out what columns have what constraints, then I can look at this specific column. I can look at this dictionary to find that information. I will skip the table space and partition objects for the moment and continue talking about other objects. I'm going to come back to this later on today. But there are a few more objects that we need to look at before we look at the storage part of the create table statement. So let's go there for a, let me pull up the slides. Right, so we have talked so far about tables and we basically talked about the create table statement, if you will. And we still have to look at sequences. So these are things that are added. These are things that are added in your schema, so you can generate unique numbers for primary keys. These are shareable objects. So when we create a sequence, we have an object that we can use to generate primary key. Primary key in the values, especially if it's a numerical value. I mean, we don't have to use sequences, but in your lab 8, I require you to use them so we can learn how these work. When a sequence is created, we have all these options. And because we are really trying to create something that works with numbers, we have these different parts that we'll look through in detail in the forthcoming slides. So we have a sequence definition here that we are intending to create for the department number. It increments by 1. It starts with 91. Max value can be 100. So this will ensure that the sequence, at least if used with the insertion of the values for the primary key, will be no more than 100. So we will basically allow an addition of a total of 11 departments. No cache and no cycle. No cache refers to, so sequence creation can work ahead and pre-generate the values. And this is just for performance. So, you know, it may, if we go from 91 to 100, and if we say cache, then it can generate 5 values ready in memory to be inserted. And no cycle meaning going from 91 to 100, and when it reaches 100, it cannot go back to 91 again. So sequences have their own dictionary view called user sequences, and so we can find all the properties of a constraint using this dictionary view, user sequences. So you can find sequence name, min, max value, what's the default increment by, and all that good stuff. Then we have 2 more properties that are worth learning, which is next val and curval. Next val will return the next available value in the sequence. The reason we are using sequences is so we don't have to think of the values for the primary key. So next val, if last time I inserted a value of 92, the next val will return 93 based on the example that we were looking at. And curval obtains the most current value, so at least you can query what the last value was that was inserted. this is how we use NextVal and CurveVal. Like in this case, we are inserting a new marketing department located in San Diego. So you can see for the primary key, I'm using the NextVal with the constraint. This is something you're expected to use in Lab 8. You can modify a sequence using the alter sequence clause, and you can modify all the properties that you see here. Okay. So how is the sequence used? Caching sequence values in memory it allows for faster access to the values. If gaps in the sequence occur, that usually is a function of an unsuccessful event in insert. So if I'm trying to insert data and I'm caching, then the probability is that I'm going to end up with a gap. So for that reason, no cache option is always pretty good. And we can use the alter clause to change the properties of the sequence. With the alter clause, and these changes only it affects the future. It does not affect the older values. So sequences can be dropped and recreated to restart the sequence. And this is how we drop the sequence. So once the sequence is removed, it can no longer be referenced. Any questions from you guys so far? Everyone is doing okay? So let's do this. Let's take a short break, about 10 minutes, and we come back and we will continue with synonyms and storage management. So back in 10 minutes, folks. So we talked about creating tables, constraints, and views before the break. So now we'll talk about creating synonyms. We also have to talk about indexes by hopefully next week, but we'll see how things go. So synonyms are something we create to simplify access to objects, we can shorten the names. Like if there is a lengthy name, we can try to shorten that. So the way a synonym is created, we simply say create synonym, and then we provide the object name. And this is an example of how a synonym would be created. So there's a create and drop. There is no alter. We also have indexes that we are going to be creating for different kinds of So now if we create a primary key column in a table, and index is automatically added. And index is a schema object that speeds up the retrieval of rows by using a pointer. And what that basically refers to is if I'm looking up a value in the where clause, and if an index exists, then instead of looking at every single row in the table, I can just look up the index, find the row ID, and access the value, which in turn reduces disk I/O. Because we have rapid access available. So when indexes are created, basically each index looks like a table and is independent of the table it indexes. It's an independent object, but at the same time, if you end up adding a new row in the table, then the index is in fact automatically updated. So that refers to the last point, that index is automatically maintained by the table. So there are different types of indexes. One is the primary key index, and I'll do a gentle introduction to indexes today, and we'll talk about storage management. And then once we talk about storage management, we'll talk about indexes in more depth. So when we create a primary key, or a unique constraint, the database will add index automatically. We can also create indexes manually on, like non-unique columns to speed up access. But we want to be careful about not to over-index. Like we don't want to add too many indexes, because then it becomes a delicate balance between data access and index maintenance. So those are decisions that are made based on the usage of the table. If you end up adding too many indexes on a table, it's possible that if you end up adding too many indexes on a table, it's possible that the index may it may slow down the queries or it may slow down certain operations with the database table. So like if I have lots of indexes and if I end up doing an insert, it might take longer to do the insert, but the query will be faster. So an index is created using a create index clause, and it can be created on one or more columns. Generally that becomes a composite key. So in this case we are saying create index name on table, and we provide a set of columns. So when do we create indexes? We add an index when a column is frequently used in the where clause or in the join condition. The column can have lots of different values, or a column has a lot of null values, or you're using a join condition in the where clause, and you're doing lots of queries on it, so you end up creating an index on that in that case. And we have a large table, and we are only accessing 2 to 4% of the rows. So all of those factors contribute to creation of the decision. Contribute to the decision for making an index. And this is when not to create indexes, because in such cases the entire table is like loaded in memory, so you can pretty much avoid the creation of the index. If you are updating the table far too frequently on a small table, then basically it's saying that the rate of change in the table is so high that it will be updating indexes frequently, just adding to the overhead, which will not be, which is not recommended. There are index dictionaries that allow us to query the index information, and when we query the index info, we can user indexes tells us the index info, and user in column tells us which columns are involved or which columns are indexed. That becomes pertinent, especially when you're trying to deal with query performance. You have to have access to that info, because indexes are generally created by, if they were created previously by someone else, we just have to know what indexes exist. So if there are some queries that are based on certain expressions, then we can create a function-based index, and we can pre-calculate those values. Like in this case, we are creating an index on column 1 by adding a value 10. So if we are doing queries that need a pre-calculation, then function-based indexes can make that faster. So function-based indexes do have an overhead as well, in that the indexes have to be maintained with each insert, update, or a delete. This is how indexes can be dropped. So then we have indexes that can either be unique or non-unique. Anything that's created with a primary key is a unique index, which basically means there are no duplicate values allowed. Non-unique imposes no restriction, so you can put all kinds of values, but there is always a performance issue with the unique index. And if you have null values, those are considered to be distinct with unique indexes. We can create unique indexes by using the create index clause, and these are also created, like I said, with primary key or unique key once that is added. So. Then the question is on index storage, and I would like to look at this index storage along with the topic of storage management, which we will cover next time. So I'm going to not talk about this today, but we have talked about the 5 different type of objects that we are going to be creating in lab 7. So you guys knowing how to create tables, working with constraints, synonyms, views, and sequences are the important artifacts. So you guys will be finishing up your lab 6 today. So I think, yeah, the 5 kind of objects we talked about are tables, indexes, starting point at least, synonyms, views, and sequences. These are going to be used in Lab 7. So in Lab 7, let's talk a little bit about that. In Lab 7, what I'm expecting is you're going to create tables. So part of the information for Lab 7 will come to you guys on the 13th, because we still have to talk about table spaces and storage management. But what you can do is start working with the create table clause for assignment 6. Once you deliver assignment 6 today, my objective will be to grade it for you, so you can start working on part 1, creating the tables with constraints, columns, any synonyms and sequences that need to be created. You will be able to start with all of that work. And then when we come back next week on the 13th, we're going to be looking at how partition table spaces and all of those work, and then we will wrap up assignment 7 by next week. And then assignment 8 is about adding data into the tables that you end up creating. So you guys can get started, and one of the things I'm going to try and do is every assignment 6 I'll try to turn it around in less than a day or a couple of days of its arrival. So my assumption is, since it's due today, I should give you all the feedback on the assignment 6 in the next 24 to 48 hours. So. Okay. Any questions from anyone, folks? This is all for today. I am trying to make the MP4s of some of these videos, because some of you guys have requested, and I learned about the service that 3C Media offers, and or that CCC Confer offers. It's called 3C Media, and they said that once that service is set up, the video conversions happen in a matter of couple of days. So today's lecture, for example, might be available by the end of Thursday. So we'll see how that goes, but the CCC Confer link will definitely be available within 24 hours. Okay? Have a great rest of the day, everyone, and I'll see you all same time, same place next week. Take care, everyone.